Welcome to Embedded System Course Project Presentation. I am Ömer.
I am Sercan.
I am Selçuk. We design a smart pet caring system project for embedded system design project. We use recyclable materials to minimize our project cost and make it environment friendly.
Our project has three main modules. The first one is the environment module, the second one is the water module, and the final one is the feeding module.
My system uses two sensors. One is the BM280 to check the environment, and the other is the SHT30 for humidity. Both sensors communicate the STM microcontroller using the I2C protocol. In this setup, the STM creates the clock signal and manages to line. It acts as the master. The sensors wait for commands act as the slaves. This master-slave style allows main device to communicate on the same line because each sensor has a unique address. The master controls them on the same bus without any errors. When the temperature goes to above 21 degrees Celsius, the microcontroller sends a signal to the relay. This lets the battery power flow the DC motor and turns on the fan. I use relay because the STM board cannot provide enough current to run the motor by itself. I use humidity data from the SHT30 to see if the food might spoil. I track temperature and humidity for both the air and both food area separately. All this data is sent to Sercan's STM board using UART communication.
I received the data from the Ömer's STM with UART communication protocol. I have two sensors here. One of them is the temperature sensor for the water, and the other one is the distance sensor here, which just measures the distance just for controlling the water level. When it decreases below the value that we determined, the DC water pump inside here begins to work and transfer the water from the water tank to the water container here, where the pet drinks the water. But the DC water pump works with 5 volt DC, but STM32 GPIO output pins gives maximum of 20 milliamperes, which is insufficient to run the pump. So I set up a relay circuit here. When the distance decreases below the determined value, this external DC battery feeds the DC water pump and the water container starts to fill up. And also I add the water temperature value to the data that comes from Ömer's STM and then transmit all the data with UART communication protocol to the Selçuk's STM.
I receive all data values from Sercan's STM to monitor the all important values on LCD screen, to be able to see all important values on one hand, and then for feeding bowl weight measurement, I use HX711 and load cell to measure the weight and compare the weight with desired values, and if the weight is less than desired value, I send impulse one of my STM32 output GPIO and activate the SG90 servo motors, and it automatically open the feed storage gate, and I automatically add the feed on the feed bowl, and that's all. And I use these things to represent the feed because I couldn't find the real one.
Let's start the simulation part.
The water level is decreasing now and we expect to increase it automatically.
When the temperature increases, fan is run.